Welcome everyone. In this video I am going to talk about differential equation of first order and higher degree. I already have uploaded one video in which I have talked about the same topic, but in that video I talked about those differential equations which were solvable for P. But in this case I am going to talk about differential equations which are solvable for Y. What does it mean? It will be clear to you in the video if you watch it till the very end. So originally what we have a differential equation which appears like f of, if suppose I consider it as a function, so it has three variable x, y and p that is equal to 0, right? Now what we do in this case, if we have an equation which appears in this form, the first process is to solve it for p, which we already have discussed. So in this what we are going to do, we are going to solve it for y. So solving it for y means what? That I will rewrite this equation in the form of y is equal to a function of x and p, right? So I can write y as a function, suppose g, which is a function of x and p. After that what we do, we find dy by dx, means we differentiate this equation, and when we differentiate this equation we get an equation which appears in the form of x p dp by dx is equal to 0, and then we further solve it. It is better to take examples to understand the process, otherwise it will not make much sense to you. So I am going to take 3 examples, and if you understand these examples you will be able to solve all kind of problems. But only thing is that you need to be careful, and it is better if you can take a pen and paper and solve it together with me. So here if you look at this equation, it contains 3 variables, that is y, p and x. So what do you think, solving it for p is easier or solving it for y is easier? I believe that solving it for y is easier, because I can write y is equal to 2px plus tan inverse xp square. I hope you agree to this, because I have written y in one side and all the other thing in the right hand side. So this is, let us consider this equation as equation number 1, and this is the first step. Now the question may be asked that how do I know that whether we should solve it for p or whether we should solve it for y? That depends upon the nature of the problem. If you look at this problem, I hope that it is not very difficult to see that it is easier to solve it for y. So that is why I have solved it for y. Now in the next step what we do, we differentiate both sides with respect to x. So I will differentiate y, so it will become dy by dx, and here 2 is a constant, so I will write 2 d by dx of px. I am writing it for your understanding, otherwise I could have written it directly also, and then d by dx of tan inverse xp square. Now as you know that what is dy by dx, for dy by dx we write p, right? And then we have 2, and how do I differentiate? So here I will use the product rule, p as the first function and d by dx of x is equal to 1, so no need to write, and then x, and then I write dp by dx. And what we get here, if I differentiate tan inverse xp square, so you know it is 1 plus x square p to the power 4, and then we have to differentiate xp square, so x, and differentiation of p square is 2p dp by dx, product rule I am using, and plus p square, and dx by dx is equal to 1. The basic differentiation I hope you are clear about, because here I have used the product rule. Now we have to simplify this, so I am going to write it, p is equal to 2p plus 2x dp by dx and plus 2px, here you have 2px, divided by 1 plus x square p to the power 4 dp by dx, and plus p square by 1 plus x square p to the power 4. Now as you can see, I can take the p in the right hand side. So if I have to take p in the right hand side, here we have 2p, and if I take this p, I will get simply p, and I will get other terms will remain as such. So I will get 2x dp by dx plus 2px by 1 plus x square p to the power 4 dp by dx and plus p square by 1 plus x to the x square p to the power 4 is equal to 0. Right. Now before I move to the next page, I just want to show you something. Right. What I want to show you, that I have to factorize this. So to factorize this, you can clearly see that you have to take these two terms together. If you take, let me explain it here. If you take these two terms together, and from these two terms you can take what common? You can take p by 1 plus x square p to the power 4 common. So here you will get p, and here you will get 2x dp by dx. So it can be factorized. Let me continue in the next page. So what I am saying, that the first term p plus 2x dp by dx, I am copying as such. So p plus 2x dp by dx, no change. And from the next two terms, what we get, we take this p by 1 plus x square p to the power 4 common. So I take p by 1 plus x square p to the power 4 common. Right. If I take that term common, from here I get p. So the first I get p, and from this term what I get, since I have taken p and this denominator common, so I will get 2x dp by dx. So I get 2x dp by dx is equal to 0. Now in the next step, what we have to do, I can take p plus 2x dp by dx, and here we have 1 plus p by 1 plus x square p to the power 4 is equal to 0. Now this is a very important step here. Let me explain the process once again, because if you will understand this, you will be able to solve all kind of problem. So what is my approach? My approach is that first we have solved the equation for y, and then I differentiated y with respect to x and replaced dy by dx by p, and then I did some did some simplification, and after that I have got at this step. Now what we have to do, we have to consider that factor which contains dp by dx. So basically the process is that when you differentiate, you try to solve it to get the form of x, p and dp by dx. Now you may ask me that what about this? What we can do for this? So we just ignore this. So what I am going to write, I am going to after this step, what will be written? It will be written that p plus 2x dp by dx is equal to 0. Now you may ask me that, sir, what about this? It can also be considered to be 0. Yes, it can be considered to be 0, but for the time being I am going to ignore it, because this will contribute to the singular solution. You might not be aware about the term. I will explain this when I will be talking about Clairaut's form, but since we are solving the differential equation to find the general solution, we ignore that part which will contribute to the singular solution. So I just consider that part which contains dp by dx. I repeat it, once we factorize, in the end we are going to consider that part which will give me the expression involving dp by dx. Now I will solve this. So this is another very important equation, so I am calling it 2. Let me call this, already I have called it equation number 1. Now I want to solve it in terms of p and x. So what I do, I write it 2x dp by dx is equal to minus p, which can also be written as 2 dp by p is equal to minus dx by x. I hope you understand variables are separable kind. So after this I will integrate both sides. So if I integrate both sides, I will get 2 ln p is equal to minus ln x plus ln c, right? So this can be written as ln p square, and if you bring it in the left hand side, it will become plus ln x is equal to ln c. So we get p square x is equal to c. Using the property of log, I can write p square x is equal to c, and this is our third equation. Now here it is important. The important thing is that once we solve the equation number 2 to get the solution in terms of p and x, the next step is that we have to eliminate p from the equation number 1 and equation number 3. Now here there are two possibilities. The first possibility is that it is possible to eliminate p. If it is possible, then we eliminate p and write the solution, or if it is not possible, then we write both equation 1 and 3 as the solution and say that p is the parameter. What basically it means, but here it is easy. So what we can do, we can eliminate p. So how can we eliminate p? The p square will become c by x. So this p will become under root c by x. So to eliminate p, just let me make some. So what I have done, I have rewritten both the equation number 1 and 3 here. So you can see the equation number 1 is 2px plus tan inverse xp square, and equation number 3 here is p square x is equal to c. So sometimes if it is not possible to eliminate p from these two equations, what we do, we say that this is the solution. This is the solution where p is the parameter, right? This is how we represent the solution. But in this case it is easier to eliminate p. So how can we eliminate p? We can write p square is equal to c by x, and so this will give me p is equal to under root c by x. So from equation 1 I will get y is equal to 2x. In place of p I can write under root c by x plus tan inverse, and xp square is nothing but c. So this is my answer. So some students can also say that this is your answer, but since it is easier to eliminate p here, we can eliminate p and get the solution. Okay. So I hope you have got the process. In case if you have not got, let me quickly explain it. So this is the differential equation given. In the step number 1, I wrote y in terms of p and x. Then I differentiated y with respect to x and replaced dy by dx by p. And after that, I solved it to get the differential equation in terms of px and dp by dx. I repeat it. I solved it to get the differential equation in terms of px and dp by dx, and I ignored the other term. This other term will contribute to the singular solution. Now the question may be asked, what is singular solution? That is something that we will talk about in a separate video. For the time being, you can just consider that this factor is ignored, right? And once we have a differential equation in terms of px and dp by dx, we solve it to get the expression in terms of p and x. So we solved this and got the equation number 3. Now I take equation number 1 and equation number 3 and try to eliminate p. If we are able to eliminate p, then we can eliminate and write that as the solution. If we are not able to eliminate p, then we simply write both of the equation together and say that this is the solution where p is the parameter. I hope you know what is the parameter. You might have studied about parametric equation of a parabola. If I am not wrong, it is something like x is equal to 2at and y is equal to at square. So it can be seen as that y square is equal to 4ax. Have I written it correct or have I made some mistake? I think it is slightly different because I think we take y is equal to 2at and x is equal to at square. Okay, so this is what the parametric equation of a parabola is. Yes or no? It is something that is used. Similarly, you must have seen about the parametric equation of a circle or something. So that is the way to represent the equation also. Now let us take this problem. Okay, so in this problem also it is already given y in terms of p and x, so they already have kind of hinted you that you don't have to do anything. It is already written, it is already given y in terms of a function of p and x, right? So we are actually already done with the first step. Now what we have to do, we have to differentiate y as I have done in the previous problem. So I differentiate y with respect to x, so it will become dy by dx, and 2 is a constant, again using the product rule, p plus x dp by dx. And if I differentiate the second one, I get n p to the power n minus 1 dp by dx, right? So dy by dx is equal to p, so this is p 2p plus 2x dp by dx plus n p to the power n minus 1 dp by dx. Let us simplify it. Take p on the other side, so 2p minus p will become p. So p plus 2x plus n p to the power n minus 1 dp by dx is equal to 0. I hope you got it. I took the p on the other side, so 2p minus p will become p, and from this I have taken dp by dx common. Now how to solve it? We are in this problem not getting the other factor, so we have got the equation in terms of px and dp by dx. So if you have studied differential equation earlier, you might be aware that it can be written in the form of a linear differential equation. Have you studied about linear differential equation? But to write it in terms of linear, let me write few more steps, then it will be possibly more clear to you. So I write one more step. I write 2x plus n p to the power n minus 1 into dp by dx is equal to minus p. Now one thing I can do is that I can take the whole thing in the right hand side, so I will get minus p by this whole expression, but that will not lead us to anywhere. So what we can do, and this is a crucial step, so you need to pause and think about it. What I am suggesting, that will you agree if I write it dx by dp is equal to 2x plus n p to the power n minus 1 by minus p, because dp by dx will be what? Dp by dx will be minus p by whole thing, but what I have written dx by dp is equal to 2x plus n p to the power n minus 1 by minus p. You may ask that what is the benefit of it, so that I will explain. The benefit of it is that this expression can be now written as minus 2x by p minus n p to the power n minus 2, right? And if I bring this in the left hand side, I am moving to the next page. What I am saying, that after this I will write dx by dp and plus 2x by p. This is what I have written, dx by dp, and I bring it in the left hand side, so plus 2x by p, and in the right hand side we just have minus n p to the power n minus 2. So in the right hand side we have minus n p to the power n minus 2. Now I hope you all remember the differential equation which is linear, which appears in the form of dy by dx plus py is equal to q, where this p and q are function of x. Do you remember this from your earlier classes? So here you can see that we have dx by dp, and here we have p, so in place of p we have this term 2 by p, and this is our capital Q. So how to solve this kind of differential equation? First you find is the integrating factor, which is e to the power integration of 2 by p, I think dp. Yes or no? So it will be equal to e and 2 log p. So 2e to the power 2 log p is basically p square, and then you write the solution. So the solution is you take x into the integrating factor, because here the dependent variable is x, and then you multiply the right hand side, that is minus n p to the power n minus 2 by the integrating factor, and then you integrate it with respect to p plus constant of integration. So let's write the last step. Xp square is equal to minus n, and here it is p to the power n minus 2, and here it is p square. So p to the power n, if I integrate it, I will get p to the power n plus 1 by n plus 1 and plus c. So here we have got xp square plus n by n plus 1 into p to the power n plus 1 is equal to c, and this is my equation number 2. What was my equation number 1? This was my equation number 1. So how to write the solution now? Now if I write the equation number 1, which is y is equal to 2px plus p to the power n, y is equal to 2px plus p to the power n. So this is my equation number 1, and then xp square plus n by n plus 1 into p to the power n plus 1 is equal to c. This is my equation number 2. Now in this case, it is not very easy to kind of eliminate p from these two equations. Do you think it is easy to eliminate? I feel that it will be slightly complicated here to eliminate p from these two equations. So what I will do, I will just write that here this is the solution, this is the solution where p is the parameter. It is kind of parametric solution where we have written the solution in terms of p, and we have the equation in terms of x and y. Yes or no? So I hope you are getting the process. Let us look at this once again so that you are clear. What I did, I took y, and it is already in terms of p and x, so I calculated dy by dx, replaced it by p, and then I got a differential equation in terms of px and dp by dx, or dx by dp, whatever may be the suitable case. Solved it to get the equation number 2, and then I took both equation number 1 and 2 together to write the general solution. Before I end this video, I want to solve one more problem so that you are absolutely clear about the concept. So how to solve it? Again, you can clearly see that it is very easy to solve it for y, because to solve it for p, we have p square, we have x to the power 4, so solving it for y is easier. So I can write y is equal to minus px plus x to the power 4 into p square, and I will consider this as equation number 1. Now I will differentiate both sides, so I will get dy by dx is equal to minus p plus x dp by dx, right? And here we have x to the power 4 into 2p dp by dx plus p square, and x to the power 4 will give me 4x cube. So dy by dx can be replaced by p, and here we have minus p plus, not plus, it will also be minus. So minus p and minus x dp by dx. Here I have 2p x to the power 4 dp by dx, and the last term is 4p square x to the power 3. Okay, now what we have to do, we have to kind of simplify it to get the equation in terms of px and dp by dx. So I think you are smart enough to see that I can bring everything in the left hand side. So we have p here, we have minus p here, so I will get 2p and plus x dp by dx and minus 2p x to the power 4 dp by dx and minus 4p square x cube is equal to 0. Now I think I can take this first term as 2px dp by dx, and from the second, what can be taken common? So 2p x cube can be taken common. So if I take 2px cube common, from this term I will get 2p, and from this term I will get 2p x cube common, so I will get x dp by dx, that is equal to 0. So let us write the next step here. So 2p plus x dp by dx, and here we have the other factor, that is 1 minus 2p x cube is equal to 0. Okay, so now you can see here that like in the previous problem, or rather in the first problem, we are getting two factors, that is 2p plus x dp by dx and the second factor. So as you know that we have to consider that factor which have dp by dx, and this factor I will ignore because this will contribute to the singular solution. Just to make this point clear here, you might be thinking that I am just talking about singular solution, not making any comment about it. So what is singular solution? Basically, if you take this factor and you take the equation number 1, and from equation number 1 and this factor, if you eliminate p, then also you get a solution, but that solution will be free from any arbitrary constant. So those solutions are said to be singular solution. But not going into the detail, I am going to take the required factor, so that is 2p plus x dp by dx. So I take 2p plus x dp by dx is equal to 0. So I want to solve it. So how to solve it? I take 2p is equal to minus x dp by dx, or I can write it as what I can write it as dp by p is equal to minus 2 dx by x. I hope it is clear. 2p dx, yeah, and x dp. So I took the p in this side and 2 dx by minus x. Okay, minus 2 dx by x. Now I can integrate. So if I integrate, I will get ln p. In the right hand side I will get minus 2 ln x, and we can add the arbitrary constant, that is ln c. So from this I get ln p plus 2 ln x is equal to ln c. So next step is it will be ln p into x square is equal to ln c. So we have solved it. We got p into x square is equal to c. Right. So this is our equation number what? It was equation number 1. So this is our equation number 2. Now from the first and second we can eliminate p. So how to eliminate p? P will be basically equal to c by x square. So original equation is y is equal to minus px. So y is equal to minus px and plus x to the power 4 into p square. So plus x to the power 4 into p square. So if I write in place of p, I write c by x square. So I get minus x into c by x square plus x to the power 4, and p square will be c square by x to the power 4. So it will look like what? It will look like y is equal to minus c by x plus c square. Okay, and this is our solution. So we have eliminated, because here it is easier to eliminate p between equation 1 and 2, so I have eliminated. Otherwise I could have written equation 1 and equation 2 both as solution by taking the variable p as the parameter. So this is how we solve the differential equation of order 1 and higher degree, and this was the second type, and in the second type we have those problems which are solvable for y. In the next video I will talk about those differential equation which are solvable for x. That is all for this video. In case if you are new to the channel, please subscribe it and like the video as well. Thanks for watching. Have a very great day.